Hello students, today we will see surface and volume integrals. So what is surface integral? So simply surface integral is nothing but the integral over the surface, that is surface integral. Now we will understand surface integral of vector function. So for that we have to consider a surface. Suppose this is a surface S having area S. Okay, so suppose this is a point P present on the surface, and we have to consider this whole surface, this big surface, as is made up of very small elements, many number of small elements. So suppose this pink area, that is a small elements around a point P, and we'll consider this small area elements, that is ds, or small surface elements, that is ds. Now consider this is a normal to the surface at point P, and the direction of normal can be represented by the normal unit normal vector, that is n cap. N cap is unit normal vector along the normal. Now consider a vector function f x y z at point P, and the direction of vector function is this, that is f vector. Now consider theta be the angle between the normal to the surface and the vector function, that is theta be the angle between n and f. Now whatever we have quoted in this diagram, we have to write in the text. So consider we have considered a surface S of area S, and P be any point on the surface, and let surface S is divided to many elements, large number of small elements, and suppose ds is one of the element at point P. Okay, and n be the normal to the surface, and n vector be the unit vector in the direction of P, and we have already considered, and f be the vector function at point P, f x y z be the vector function at point P. Now the component of f along the normal to ds is f cos theta. Okay, so suppose component along the normal, the component of f resolved along the normal, that is f cos theta, because adjacent component is cos theta and perpendicular component is sin theta. So we have considered this, the component of f along the normal and to ds, that is f cos theta. Now we consider the product of this component f cos theta with small area element, that is ds. So the product of f cos theta and ds at point P is nothing but f cos theta ds. So f cos theta ds can be written in this way also, f ds cos theta, f ds cos theta. Now this f is the magnitude of vector f, and ds is the magnitude of ds vector, and this is the cosine of angle between them. So this is nothing but the formula for dot product. If dot product between two vectors is nothing but magnitude of two vectors, product of magnitude of two vectors, and the angle cosine of angle between them. So this may be written in this way by definition of dot product or scalar product, f dot ds, f vector dot ds vector. F ds cos theta can be written in this way, f dot ds, f vector dot ds, or ds vector can be written in terms of unit vector into ds, because we know that unit vector is nothing but that vector divided by its magnitude, so ds vector can be written as n unit vector into the magnitude of that vector, so n cap into ds. So f dot ds can be written as f dot n cap ds. Now this product is only limited to one small area element, that is small surface element, but that big surface, that big blue surface is made up of this blue surface. Okay, that big surface is made up of many number of the small elements. So that product is only limited to what? That product, above product, is only limited to the small surface element. But if I want to consider whole surface as, so we have to integrate this product. If I want to find out the product for whole surface, so we have to integrate this product, okay, over the surface. So we have to take the surface integral. So suppose this is surface integral for whole surface as this product will become a surface integral, that is surface integral means that is double integral over the surfaces f dot ds, or double integral over the surface f dot n cap ds. So this is the equation number 1, and this equation number 1 is known as the surface integral of vector function, where f vector is a vector function. Suppose surface is closed. If surface is closed, not open, so this integral, surface integral, can be written in this way: for closed surface, surface integral over closed surface. Okay, this is the circular sign which can be given in the middle of integral. So this is for closed surface, f dot ds, double integral over closed surface, f dot ds. So this is equation number 2. So the integrals in equation number 1 and integrals in equation number 2 are known as surface integral. So the integral in 1 and equation number 2 are called surface integrals. Okay, so what will be the definition then? Surface integral of vector function, surface integral of vector function over the surface S is nothing but the scalar product or double integral of dot product of that function, vector function, and the vector of small surface. The dot product of vector function and small vector of small surface element, this is nothing but the surface integral of vector function. So definition is, some surface integral of vector function over the surfaces is double integral of dot product of that function and the vector of small surface element. So if we solve this f dot ds, we will get f ds cos theta. So f cos theta is component of f. So in terms of component, that definition can also be right in terms of component. So surface integral of vector function f over the surface S is the double integral of component of f, and the direction of component of f is along the normal to the surface. So the surface integral of vector function f over the surface S is the double integral of component of f along the normal to the surface. So definition can be written in either way also. So these are the definition of surface integral of vector function, and this is the expression of surface integral of vector function. Okay, now we'll move towards volume integral of vector function. Okay, so volume integral can be represented in terms of triple integral. So what is definition? So this is triple integral over a vector function, the triple integral over whole volume, triple integral of vector function over the whole volume is nothing but the volume integral. So triple integral of vector function fxyz over a volume enclosed by this closed surface is nothing but volume integral over the volume v. So this is the definition of volume integral of vector function. If suppose f is scalar function, then it will become the volume integral of scalar function. So today we have seen surface integral, its mathematical expression, volume integral, its mathematical expression, okay, and description about them. Okay, thank you very much.